All right. Hi, everyone, and welcome to GraphQL in 2016. It's really exciting to see so many people here, and yeah, we didn't think that when we organized this meetup just about 2 weeks ago. We also have a great lineup of speakers tonight, including people from Facebook, Joe Savona, and then we have the creator of Graphene, Cyrus Akbari here. We have my colleague Sashko Stubailo, who's working on Apollo Stack, and we have Clay Alsop, who built GraphQL Hub. So my name is Jonas Helfer. I also work on Apollo Stack here at Meteor. And I'm going to give you a very quick intro into GraphQL for those who are not super familiar with it yet. I'm sure the other speakers will also give you things like that will help you understand GraphQL better. And then there's plenty of resources online that you can go to look it up. OK, so here's GraphQL in a nutshell. GraphQL is basically, why do I still hear the music, by the way? OK, yeah, never mind. Sorry. So GraphQL in a nutshell. GraphQL is a layer between your backends and your front end. So you can put that in, and it's a nice layer of abstraction that will help your front ends communicate with any backend. So that can be any kind of front end. It can be an iOS client. It can be Android. This can be React. It can be Angular, anything you want. And backends, it's the same. It can communicate with REST backends. It can communicate with SQL. It's all up to you to set it up. So GraphQL is really just the nice layer of abstraction in between that's kind of been missing from RESTful APIs. What's really nice with GraphQL is that clients can fetch all the data in just a single round trip. So they fetch all the data necessary for a view to be displayed in a single round trip. Now contrast that with REST endpoints, where you either split up your REST endpoint to have one endpoint for each model, and then you have to do multiple round trips to put together all your hierarchical data, or you make custom endpoints for just each view. In GraphQL, you don't need to do any of that. Different clients all use the same endpoint. They fetch all the data for one view in one round trip, usually. What's also nice about GraphQL is you will not have any overfetching and you will not have any underfetching. Clients specify exactly the data that they need, and the GraphQL server sends them that data in the shape they ask for, not more, not less. What that also means is that you don't have headaches with versioning of your API anymore. If you have iOS clients that, where people don't update their app for 4 years, but you still want them to be able to use your service, you don't have that headache with GraphQL because you can just add new fields, and those old clients can keep sending their queries, get exactly the data that they want, while new clients that support the new feature get the data that they want with the new features supported. A really nice thing about GraphQL is that it's strongly typed. So what that means is clients can ask, what does this server support? What is this field? What is this type? Is that an integer? Is that a string? How do these different types relate to each other? And with that, you can build amazing tools like Graphical, which is an in-browser IDE for exploring your API. You also get your documentation essentially built in. And my colleague Sashko Stubailo has actually made an ESLint plugin that will let you, as you type in your editor, will tell you when you're writing a query for GraphQL that contains a typo or that's asking for data that's not there. Now imagine if you could do that with your REST endpoints. If you could write a URL and your editor would tell you, oh, actually, you need to use a different argument here. With GraphQL, you have none of these problems. So just a very quick look. On the left here, we have a GraphQL query. As you can see, it's sort of like JSON. It's a hierarchical query. And here we're asking for a first name of an author and all the posts that this author has written, along with the title. And on the right side, we get the reply. And you'll see the shape of the reply is actually the same as the query, which is another really nice thing about GraphQL. Now, if you had another client that also wants the last name of the author, that would be easy to do, and you would just add that field. So here, sort of to emphasize the contrast with REST-like or RESTful, I don't want to get into an argument, what's proper REST, but usually REST APIs will kind of look the way you see on the left side, where you have different endpoints for different types of data, and they might talk to one or more databases in the backend. So how you wire that up is really up to you, and you put that into your REST endpoint. Now contrast that with GraphQL on the right side, where you really have one endpoint, and all clients talk to that one endpoint, and they send a single query, and then the GraphQL server figures out which backends to talk to get the data. And so GraphQL is really more of an idea. So GraphQL has a specification. It's not an implementation. It's not for a specific language, for a specific type of technology. It's really an idea. And there are many implementations in different languages. And it's really exciting to see how the GraphQL ecosystem is growing very quickly. So we have JavaScript implementations, Python, there's Ruby, there is implementations in Haskell, .NET, really a lot of them. And here I've just put a few of the logos. And actually for 4 of them, we'll have speakers tonight. So the first one is going to be Cyrus Akbari for Graphene. Then after him, we'll have my colleague Sashko Stubailo for Apollo Stack. And then we have Joe Savona from Facebook, who will be talking about Relay. And last but not least, we have Clay Alsop, who will be talking about GraphQL Hub. So without further ado, I'm going to hand over to Cyrus Akbari, the creator of Graphene, who will be talking about implementing how he implemented GraphQL in Python and what you can do with it.
That's it. Thank you. I'm worried that it will. Okay. Good for me. Hello, everybody. So I'm Cyrus Akbari. Today, I'm the creator of Graphene. Graphene is a framework for Python that let us create GraphQL schemas or operate with GraphQL in Python very easily. And today I'm going to talk about what is GraphQL. Jonas did a very great introduction, but I'm gonna do it too. Then we'll see a little bit about Graphene, but not too much. And then we'll research about what we can do to make GraphQL better as a community. So first slide, what is GraphQL? I want to ask you, how many of you already know what is GraphQL? Please raise your hands. Lee. Perfect. OK, so it's almost half and half. So I'm going to say almost the same thing as he did. So GraphQL is a query language created by Facebook that let us query exactly the data we want without underfetching or overfetching data. So if we expect to receive this data, this is how actually we have to query. So as he said, the GraphQL query just looks at the JSON, but without the values. And that's great. But what's the real thing? What we really love GraphQL? The main reason is because we swap the responsibility of querying from the server to a client. So if before we have all this data just in one RPC endpoint in our API, this logic were living in the server, and actually when we want to add a new client, like Android or whatever, we have to add this logic again into this RPC endpoint. But actually, it makes more sense to let the client the data it wants, and not the server. So let's go again to this example. So we want to fetch a user, me, and we want to fetch the fields name, company, and friends. And from friends, we want to fetch the name. So in GraphQL, we define the root query, which is the root type that we access when we query. And this root query type have the me field, which is returning a user type, which have name, company, and friends on it. And friends is just returning a list of users. So for example, if you're Python guys, this is how you have to implement it in Python. And actually, it's not very readable. It's not very easy to follow what's happening. So while I was deploying in Python, while I was trying to make GraphQL schemas in Python, I realized that I didn't like the way of writing GraphQL schemas. It was not natural for me. So why cannot make it simpler? That's the main reason I decided to create the framework, Graphene Python. As I told you before, Graphene Python is a framework for operating with GraphQL in Python very easily. So let's see an example and see how it works. So we define classes and types We define GraphQL types on top of Python classes. Then we define the attributes that act as GraphQL fields, and we define what are these attributes. So for example, name is a string, company is a string, and friends is just a list of self, which in this case is a list of users. And me is just referencing the user. And also we move the resolvers to the class. So actually it's much easier to see where our resolver belongs. So what are the main features of Graphene? We have integration with Django, SQL Alchemy, and as of 2 weeks ago, we also have Google App Engine support. And thanks to Eric Kamp, because he did a very great work on that. And also, we added 2 weeks ago middleware, which I'm going to research a little bit what is middleware actually in GraphQL. So also, I would like to give thanks to our community as today Graphene is the most started non-JavaScript GraphQL repository. So thank you, everyone. So next question, how we can take GraphQL to the next level? What we can do to make it better? So while I was working with Graphene in the backend and Relay in the frontend, I realized a lot of things that could make the effort of developing GraphQL schemas much easier. So one is live queries. If you see my presentation in the React.js Conf, I was trying to accomplish this thing. But after researching a lot, I realized how hard it was to implement live queries without imposing how we have to handle that. I actually like the way Reactive-X is doing, but I just want to wait until Lee, Byron, and probably Meteor finds a good solution for that. Next one, validation. What I mean with validation, if we actually already have validation in GraphQL, right? So imagine we want to create a user and we use the GraphQL mutation. A GraphQL mutation is just an action that we take in our data, in our GraphQL schema. So we want to create a user and we expect to receive age as an integer and we receive a string. Then GraphQL do a great job there and just like don't let us to run this query. Like it will stop the execution because the data, the query that we are doing is not valid. But what happens, for example, if we want to create a user and we expect to receive an email, but email, as all we know, email is a string, right? So in GraphQL, for handling this thing, we can either create a new type, an email type, which is kind of a string with validation, or we can add the validation in the resolver. But if we do that, what happens? The validation will be only available server-side, as it's living in where the resolver lives. So it's not very easy. It's not very easy now, sorry. It's not good because we cannot replicate easily in our client. And also, it will be validated, but not stopping the execution of the GraphQL query, which is bad. Actually, if we are running mutations, we want to stop if we are not doing a valid query, right? So what's the proposal here? One thing that we can do in GraphQL is just a new type into the schema, which is a validation type. Or we can also use directives. So another thing I would like to talk about is the planning phase. What I mean with planning phase? With planning phase, I mean that actually when we are querying any kind of data, when we are resolving a field, it could know what are the subfields that we are querying. And we are adding a phase between validation and resolving for fetching just the data we need. So for example, without planning phase, we will query in our database, like we will select everything. But if we have some kind of planning phase, we can know what fields we are requesting from our user and just query that from the database. So that's good. Actually, we can already do that in the resolvers, but it's not a very clean way. OK, one of the things I'm more proud of is middleware. But what I mean with middleware in GraphQL, in Express or Koa or any kind of Node.js framework, we have middleware. And what it means is we can modify the request at some point. But in GraphQL, we don't have any paths or whatever. So, but we can assimilate a URL, a URI, to a GraphQL field. So actually, what I mean with middleware in GraphQL is you can use it for affect the resolution of your fields at any time, at the beginning when you are resolving, in the middle, or after it's resolved. So this is actually already implemented in Graphene, but it's not just in Graphene. You can have middleware in GraphQL, Ruby, and you can have middleware in Sangria. So you can see how 3 very different frameworks that are not implemented in the same way, we almost got to the same approach. So let's see an example on how it looks middleware in Graphene. So this is authorization middleware that will be called each time we resolve a field, and we'll check what is the return type for this field. And if the user in the context doesn't have permission for access this return type, then we will return none. So we don't need to add this logic into all our resolvers. And that's great. But other example, for example, we want to have rate limiting in our GraphQL schema. So for implementing, the only thing that we have to do is just create a counter in the context. And each time we are resolving, we increment the counter if we resolve it correctly. And if it reaches the limit, we will return none. For example, you can raise an error or whatever you want. And that's great. So in conclusion, we all love GraphQL. So let's make it better together. Thank you. Do you have any question?
Yeah, we have a couple minutes for questions. So if anybody has a question for Cyrus.
No questions?
All right. If no one has a question, then I have a question for you.
Oh, okay.
So what inspired you to? What was the sort of first inspiration for you to create Graphene?
Okay. The main inspiration was like, so I said, creating GraphQL schemas was not easy, neither in JavaScript or in Python. Like I was not feeling comfortable with it. So as I was not feeling comfortable, I just want to create a tool where I can write GraphQL schemas very easily. So for example, when I implemented Graphene, I started with the way I want to use it before implementing anything. And once I have the syntax, which is like the true value of Graphene, I can make any kind of implementation. So actually, we do 3 very big refactors, but as the syntax remains valid, we don't have to do any change on the Graphene implementations. So that was good. I like it.
Yeah, that's great. Any questions from the audience?
I will. So you mentioned the middleware. How do you actually go about using one of those middleware? So the rate limiting middleware, for instance.
Yes.
Does that end up getting implemented on all of your resolvers, or do you how do you choose which?
It's implemented. Actually, the middleware is called always. Always. Each time we call our resolver, so we don't. Yeah, like it's this way we can check either if the return type is the type that we expect, or if we want to add rate limiting, or if we want to add, for example, we have already middleware for debugging our Django queries. So actually in the Star Wars API example that we have in the Graphene, which is the URL here, if you go here and you see the Star Wars example, and you try the debug field in the root query, you will see what are all the SQL queries executed. And this is thanks for using middleware. So you have a lot of cool things thanks for using that. And as we are using promises, also in Python, it's very easy to, like the implementation of middleware was like 10 lines of code.
Do you see a lot of your users using middleware?
We just implemented 2 weeks ago.
Oh, okay.
Okay.
Cool.
For those watching the live stream, the question was, how do you actually use middleware, and how do you decide where to apply it or where it doesn't apply? And we just heard the answer before.
Yeah. Other question?
All right, there's another question. Yeah.
What do you think is the biggest missing component from the GraphQL ecosystem right now?
Okay, so the question was, what do you think is the biggest component missing from the GraphQL ecosystem right now?
I really think validation should be something. I did a pull request and not a pull request, I opened an issue for discussion about that, and I think that could be really useful. Actually, I'm a little bit scared about directives because it opens this Pandora box where everything could be a directive, and I just want to make sure that we know what using a directive is. But for me, validation is something that is quite important. And it's important to stop the execution. So I think it should be recorded.
All right, let's thank Cyrus again for his talk. Okay, our next speaker is my colleague Sashko Stubailo, who will be talking about Apollo Client, GraphQL client for any type of JavaScript framework, front-end framework, that is.
Great. Yeah, so you guys heard just now a bunch of stuff about backend GraphQL, but that's not usually where I live. I think for all of my programming life, I've been a front-end developer. I only learned how to write a line of PHP like maybe 4 years after I wrote my first line of HTML and then JavaScript. So anyway, that's a lot of cool stuff. But what I want to talk about is how do you put GraphQL data in your UI? There's a lot of great answers to this question, actually. If you probably Google around for GraphQL clients, there's a lot of different options out there. But I think the thing that I really want to focus on with Apollo Client is just answering this question in the most straightforward way humanly possible. Because GraphQL has a lot of really great tools that are really fun to use. For example, if you guys have used GraphQL at all, you might have seen this tool called Graphical, which I think is like the greatest thing handed down from the benevolent GraphQL dictators. I think it's the kind of thing where you can talk about GraphQL all you want, but I think this is the moment when you see this tool where you just explore your schema and you type the fields that you want and you get exactly the thing you asked for. I think that's when people, or at least that's when I really, really got it. And I was like, wow, like you can't do this with REST. Like, come on. There's like tons of services built around trying to do this with REST, and they're not really that good. Sorry, services. And I think like this is also the value is the GraphQL syntax. It's so nice because you could do the same thing and you could type out giant JSON objects with many fields. They could have lots of colons and brackets and fun stuff like that. But there's none of that here. It's just a very simple thing designed to do one thing, which is fetch data, and it feels great to use. And then you're like, okay, great. I've set up my GraphQL server. Maybe I used a backend as a service or something that gave me a GraphQL schema that I can explore with Graphical. But now what? Right? Now probably the next thing you want to do is build an app on top of that, because you're probably not going to give your users Graphical to play around with directly. You want to give them a UI. And what I found was there was a bit of a gap there where you have a lot of fun with Graphical. You can see exactly where it's going. But then it's not quite as easy to build an app on top of it as the syntax might suggest, as the experience using Graphical might suggest. Sometimes you have to do some complex setup. Perhaps you have to modify your schema to use something like Relay. Sometimes you can't always use the schema that you started out with. There's also not too many super great examples of full stack GraphQL apps out there. There's a couple, but there's nothing that I think really lets people get started super easily. So that's why we decided to build Apollo Client. And Apollo Client is a thing where you npm install Apollo Client, you copy and paste the query from Graphical into your JavaScript code, and you're done. You have the data in your UI. You've built an app on top of your GraphQL endpoint. And if you don't need any super special features, if all you want to do is display that data, then you're basically done. Let's go a little bit, check out what queries and mutations look like. And it's not very surprising. They look probably exactly like what you would expect, right? You take that query, you type it in the Graphical, you put that string into your UI code. It's highlighted in green here in my wonderful color scheme. You throw some variables in there. Variables are kind of like arguments to GraphQL queries. You can see that the feed query takes a feed type, which can be top or hot or one of these things you see on Reddit. And the same thing with mutations. A mutation in GraphQL is also a nice query that you can type into Graphical, and then you can paste into your app, and you can call it the same way you call any of your React callbacks, for example, just by passing in some arguments, and those get passed to the server, and the thing that you want happens. And specifically in the React integration for Apollo, we also have an Angular one, but in the React one we have some very tight integration with Redux. So you can get your data from your props of your component, from the Redux state, or from the arguments that were passed into your mutation. So what kind of features can you expect from a GraphQL client? So it's pretty easy to imagine what happens when you send a single GraphQL query to the server. But real life is not as simple, right? You're not just having your read-only display of your data. So a lot of the features that you might want out of a GraphQL client come in when you either are modifying that data or you want to refetch it in different ways. So today, in Apollo Client, you can call mutations and have the data be refetched and integrated back into your store. You can pass polling intervals or manually refetch to get new data when you want to. And you can even wire up an external data source to pipe data directly into your client-side store and see that reflected in your UI components, right? So you might have a user type in your GraphQL schema. You can just get new data about that user from WebSocket, throw it into the store, and have that update your UI. And there's a lot of great features we're thinking about, calling them tomorrow's features, probably in the next month or two. But some of the great things that you would expect from a full-stack data loading system like optimistic UI, which is the ability essentially to have a fake mutation happen on the client before it actually comes back from the server. Some nice features around pagination, just to make it easier to fetch data when you already have some of it. And the ability to do some of what Relay's most flagship features are about, which is compose fragments from different UI components into larger queries when you want to reduce the number of round trips. So what is it that enables Apollo client, or is going to enable Apollo client, to have such a simple syntax where you just copy and paste the query, but yet have all these cool features you expect from your fancy clients, like refetching, pagination, all that kind of stuff. And it's really just three things. And these are three things that I think what I would say a sufficiently smart GraphQL client should have. The one thing it should have is a normalized cache. So just like Relay, you don't want to store the results of your GraphQL queries on the client as just giant blobs of JSON, because you can't really do much with that. Because if you do two queries for the same data and you're just storing them as is in your store, there's no way to understand that those two subtrees of the query represent the same data. So you can't do something like fetch a giant query that includes some newsfeed items and then update just one item by calling that smaller query. And that's something you can do once you have a normalized cache. With query manipulation, which is basically the ability to operate on queries before you send them to the server, or maybe even at build time so you don't have to do it at runtime, you can avoid typing certain fields, right? For example, if you always want to refetch the IDs of your objects, or you always want to fetch the type names of your objects because your UI depends on that or your logic depends on that, you should be able to do that automatically. And the last thing I think is a nice store. So Apollo Client gets this for free. Thanks, Dan. So Apollo Client is totally built on top of Redux. You don't have to care about the fact that it's built on top of Redux, but it was just a super simple model that let us have a totally serializable store that moves in very concrete steps and lets us implement some of these features like optimistic UI, server-side rendering, and store hydration with basically no code because it was always supported by Redux. And of course, as indicated by this tweet I saw a couple hours ago and thought it was really cool, it works with Redux dev tools. So if you've ever had a fancy data fetching system and you're wondering when is it fetching the data, what data is it fetching, why, you can now do that just by opening your Redux dev tools. If you're already using Redux, it integrates with your existing store, and just see what actions are going on there. Oh, okay, it decided to pull this time. Okay, it decided to send this mutation with these variables from my props. So let's check out an app. So I just have a couple of simple things I want to show you about this application. I'm not going to try to do any live coding. That didn't really work out too well last time I tried to do it. But this is the app that we're calling GitHunt. I guess I should show you the app first. That would probably be beneficial. So you can actually go to it yourself and go to githunt.com. And what this is kind of like product hunt for GitHub. We chose this particular example because it's both loading data from a local SQL database and also from the GitHub API, which demonstrates GraphQL's ability to paper over multiple data sources. So let me just show you a couple of the things that we already kind of talked about. One is the ability to load a query. So you can see here we have this feed query, and that has the stuff that we wanted. I actually was editing it earlier, so let me unedit it. And let's say we want to demonstrate one of these features. So let's say we want to, for example, add a poll interval. We'll refetch it every second. I said I wasn't going to do any live coding, but sorry. So we're going to npm start this. And so now, since we just added some really simple polling, what we can do is we can take this app, we can run it in multiple tabs, which is what you would expect. And then it doesn't work. Oh, I know. It's because I don't have my GitHub API key, so don't look at that. Because we're loading data from the GitHub API, obviously we can't run without it. So as you can see, here if I log in, that's what I get for trying to live code. Anyway, moving on. You can try it out in the deployed version. Basically, if you upvote in one tab, you'll see the upvote appear in the other tab if the query is polling. So that's how you get data with a query. There's also a place where you want to be able to upvote, which is a mutation. So let's find the vote mutation. Yeah, so here you can see a mutation. This is the thing that drives the ability to upvote one of the newsfeed items. Yeah, and that's pretty much about it. That's all I needed to build this app that lets you both submit items, vote on them, and check it out. So if you just go here and you start upvoting, you can see what other people have been doing. So yeah, so you can also run this app locally if you clone it from GitHub at our repository. And I just want to go over a few of the meta goals we have for Apollo Client, because I think this could really be a cool project. So the number one thing is being totally community driven. What we want to do is we want to build the best tool for the widest range of people to just fetch data in their app the way they want it to be. So I welcome you all to come submit issues and feature requests. I can help you find different ways to contribute, small pull requests that you can do to get this stuff going. We want it to be as modular and transparent as possible. So like I said with the Redux dev tools before, we want to make it easy to understand exactly what your app is doing and not have that happen out from under you. We want to make it incremental and compatible. So we're starting with React and Angular integration, but we want to have as many integrations as possible from as many different people as possible with any view layer or technology, as well as being compatible with any GraphQL server you can find that's spec compliant. And finally, we want it to be production tested, which is why we've started integrating into our own production apps starting about a week ago, and hopefully be deployed a week from now. So yeah, that was Apollo Client. It's pretty simple, not too many bells and whistles about it, but it'll get the data from your GraphQL server into your UI. So come check it out and come contribute.
All right, questions from the audience? I have one right here.
So how closely integrated are the pieces that make up Apollo stack? Like if I wanted to just use normalized cache or drop Redux from the stack, would I be able to do that?
So the question was, how closely integrated are the parts of Apollo Client? So for example, if he didn't want to use Redux, would that be possible?
Yeah, so it's one of those things where it's modular on the inside. Right now, you would probably have a hard time npm installing Apollo Client and using it without Redux. But actually, we were just earlier having a conversation on GitHub with some people who wanted to implement alternative GraphQL clients, but reuse some of the internal machinery about normalizing and denormalizing GraphQL data. For example, one thing you could do that would be really exciting is just use Apollo Client's normalization functionality to read and write from just plain objects. So you could populate your store or your object however you want, and then just use a GraphQL query in your UI to read that out. And one more thing I want to mention about Redux is I was talking about it here because I think it's a really important part of the implementation, but you really don't have to know how it works. We also have integration on the output end with RxJS. So you can do a query with Apollo that returns an observable. That's actually how the React integration works, is it uses the observable. That's how the Angular integration works. So yeah, you npm install Apollo client, do client.watchQuery, get an observable, and use it with whatever you want.
Okay, we had another question back there.
When you were papering over the GitHub API, was that client side or server side?
So the question was, the papering over the GitHub API, does that happen client side or server side?
It happens on the server side, and there's a couple of really great reasons why. And this code is maybe not the best code that you would want ever, but there's one really interesting feature of GitHub that has to do with e-tags and caching. So the GitHub API only gives you 5,000 requests per hour, unless I assume you do something that causes them to give you more. But we figured maybe more than 5,000 people would want to use this app in an hour, or maybe look at 5,000 repositories. And so there's this great feature which says if you fetch an item before, you can send them the e-tag, which is basically like a cache key, and it doesn't count against your rate limit the next time. And so this is kind of a feature that you want when you're accessing the REST API. And what we've done here, we've implemented something that we call a connector. And a connector is something that you call from inside your resolvers. So you just do GitHub, get me this API URL, and it does the caching for you transparently. So no matter how many GraphQL requests you're doing, how many different fields you're accessing, it's always calling this connector and doing that caching globally. So if you were calling your GitHub API from the client, you wouldn't even be able to do this. And I think one of the biggest benefits of GraphQL is the fact that the client doesn't have to be aware of specifics of the API, or even what different APIs are involved in fetching a certain query. So I think while it is possible to resolve GraphQL queries entirely on the client by calling the API directly, I think I wouldn't want to do that in my production apps.
We have another question over there.
How do you
So the question was, how do you do pagination without something like relay connections?
Yeah, so I guess one way to interpret this question is this app has pages. So you can click next page and you go to another page. But that's not really what the question is about, because while this is indeed pagination, it's the ability to look at different pages of a set of data, Relay does something with cursors, which is essentially allowing you to fetch a certain segment of something like a news feed, and then tell Relay to fetch more items of that news feed, and it remembers which ones it's already fetched, and only fetches the ones that are new. And Relay implements this via a specific API interface on the GraphQL server called a Relay connection, I think is what it's called. But basically, that has certain fields that give it various cursors, the ability to get the next item, the previous item in the list. In Apollo Client, one of our main goals is to not impose that restriction. So we want to work, like I said, with any possible GraphQL server you can come up with. So our idea currently is to have pagination plugins. So remember when I told you about the phase where you manipulate the query before sending it to the client? What we want to do is have the ability for people to ship different versions of pagination that can be applied almost as middleware on the client on the query. And so you can have something that, for example, using a skip and limit, which is the most basic form of pagination, or maybe just page numbers, you can implement any custom logic you want to look into the store and see what pages you have already and manipulate the query in whatever way you want. So I think rather than implementing a spec that has a generalized version, I think I want people to be able to write any GraphQL server they feel like and then modify Apollo Client in the way they need to make it work with that schema. I don't know if that answered your question.
OK, we have time for one more question.
You consider using like a persistent data structures library like Immutable.js for normalized cache? Like, do you see any garbage patterns?
So the question was, have you considered using something like Immutable.js for the denormalized cache on the front end?
Lee's right here. It's so exciting. The creator of Immutable.js, or maintainer. Anyway, we have an open issue that's like at some point refactored using Immutable.js. So it's one of the things that you could come and help us contribute. So I see a couple of benefits from using Immutable.js. So first, we're doing the kind of regular-ish Redux pattern right now, which says you want to be able to compare objects using triple equals to check when they haven't changed. And that's one thing we do already to avoid firing query modifications when we don't need to. But that requires us to clone objects all the time. And I think Immutable.js is perfectly designed to avoid cloning objects all the time to get a similar effect. And there's also a question in there about garbage collection. I think garbage collection needs to be a little bit more semantic with how the actual store is, what kinds of queries are being watched, and when you might want to load and unload those queries. So I imagine Immutable.js will make our development workflow much easier and perhaps give us some performance benefits in certain cases, but I don't see it yet helping us with garbage collection. Right now, by the way, the store grows monotonically forever, which it turns out is fine for most apps. Actually, it only grows if you fetch new data. If you refetch the same data, it just replaces it. So.
OK, let's thank Sashko again for his talk.
Thank you.
All right, just a small public service announcement before the next talk. There's seating upstairs, so for those of you in the back, if you want to sit upstairs, you can watch the live stream from there. OK, our next speaker is Joe Savona from Facebook. He works on Relay, the GraphQL client that Facebook is developing for React, and he'll be telling us about what's next for Relay.
Hi. All right, let's get set up. Yeah. That's good. That's better. Is that better? Yeah, okay. All right. And this is the thing I always forget to do before I start the presentation, so I'm going to actually take time and get set up. This is mirroring. Why is it mirroring? Don't do mirroring. Stop. Okay. Is that good? Nope. Yeah, okay. All right, let's get started. Okay, so my name is Joe Savona, and I'm a software engineer at Facebook, and I work on the Relay core team. So you may be familiar with Relay, but I'll kind of give a brief recap just to get everyone familiar. So Relay is a framework that we built at Facebook to manage data in complex apps. And the goal is really to simplify the process of managing all these different data requirements, fetching data, paginating, mutations, all that stuff. And we really want to allow product developers to focus on the product. And with Relay, we set out, we are big users of React. Obviously, we created it. And so we wanted to keep that mental model of just component-oriented development and allow just the same way that React lets us stop worrying about DOM manipulation and focus on our UI and its design and interactions. Relay allows us to stop worrying about actually fetching data and focus on what we do once we have the data. So I think there's been a little bit of maybe confusion in the community. People kind of look at Relay, and everyone kind of brings their own perspective and I think hopes when they see Relay. They're like, oh, it's the GraphQL client that Facebook uses in JavaScript, so they have their own idea of maybe what they expect a data client to do. And so in this talk, I want to focus on the use cases that we are really targeting in order to help you evaluate whether Relay would be a good fit for you, and focus on both the use cases that we're targeting now and also what we're thinking about going forward with. So the kind of three big ones are fetching data for a view. That's pretty obvious, right? Data client. Pagination and mutations. But last but not least, performance. So none of these things would really be very useful if you could not build a large app and have it be performant enough for users to be happy. And so performance is a really big goal for us. So let's start, just kind of briefly run through these and think about how Relay solves these use cases. So fetching data for a view. In our experience, most products want basically one behavior everywhere, and that's you have some UI, you want to show it, you need a certain amount of data before you can even render anything, and so what you want to do is show a loading indicator, get all that data, and then render the entire UI. You don't want to have a little bit of text and a loading spinner, and then a little bit more text and another loading spinner. You want to just get some data as fast as you can and render it. And then maybe you're going to load some additional information after that, right? But we want the initial render to be as fast as possible. And so we wanted to make that work with React. But in React, our components are split up, right? That's the whole point, is we can decompose our UI, a complex UI, into small pieces. And so we wanted to keep that ability to reason locally about our application and yet still get this effect of all the data is fetched immediately. And so what we did is to extend React components by wrapping them in what we call a Relay container. And so basically we co-locate the query and the render logic so we can see them together. And this helps with a lot of things. So it avoids the problems of overfetching, where we are actually fetching a lot more information from the server than we actually need on the client. And there's not so much systematic in terms of tooling detecting which fields are actually used, but there's render logic here, there's query right there. You can look at them and see that I don't need that field anymore, so we'll just delete it. It also helps protect against underfetching, because again, we can just look and see, oh, I'm not fetching the list of friends, so how can I possibly render them? It also makes it a lot easier to edit our application, because if I need some more information, I add it to the fragment, and now Relay will go and fetch that information for me. So how that actually works in practice is that Relay can basically statically look at the component that we're going to render and build a static representation of the query. Send that to the server, get the data back. It basically writes it into the cache and then vends out props to the components. So each component, as it's rendered, says, hey, here's my fragment, store, give me the data for this fragment. Gets the data and then renders. And then their children go on and access data from the store. So again, kind of Relay is taking care of a lot of things for us, and basically this entire process is orchestrated by Relay. So the next thing is pagination. I mean, so we all know lists are ubiquitous in UIs. And for performance reasons, we obviously can't go and just fetch all the items in the vast majority of cases, right? And for some things, like, for example, the Facebook newsfeed, there isn't necessarily an actual like categorical, this is your newsfeed at this point in time. It's when you ask for it, we're going to generate a certain number of things that you might want to see right now. But it isn't as if there's a MySQL table sitting somewhere that has the canonical list of your newsfeed. So with pagination, and Sasha kind of talked a little bit about this, there's kind of two like high-level approaches. The sort of limit offset approach, where we say, give me 10 items after 0 or 10 items after 10. And then there's the cursor-based approach. Cursor-based approach. And cursors are really good for larger tables or that sort of algorithmic style ranked list, where we can basically say, each item has a cursor. When we want more information, we ask for more information starting from that cursor. Whereas limit offset, we've got to basically like scan through a very, very large table. Cursors are much more performant on the back end. And so this is why we've typically used them. And so in Relay, again, we try to have, like, we really focus on building a declarative API. So the client would express that I want to see the first 10 friends. Later, it might express that it wants to see the first 20 friends. We don't have to think about what we're actually sending to the server. Relay takes care of that for us. So it says, oh, you want to fetch 20 friends, but we already have 10 friends, so I'll subtract that for you. So just like React can do virtual DOM diffing, Relay can sort of do virtual data diffing and construct the query that we see on the bottom. So friends first 10 after the 10th cursor. So the third kind of high-level use case is mutations, basically data updates, writes. So there's a lot of things to cover with mutations, and I'm not going to go into them because it's worthy of its own talk. Lainey Kunzel from Facebook gave a great talk about how Relay mutations work, and that's linked to from the GitHub page, so I refer you there. But at a high level, they kind of follow like a very similar flow to queries. We have some action and some inputs. We send them to Relay. Relay sends that, constructs an actual mutation query for us, sends it to the server, gets the response back, updates the cache, and then updates any affected components. So again, these Relay containers are doing the subscription for you automatically. So they're watching the store, and if any of their data changes, they're going to re-render automatically. And because React is going to batch the updates and start from the topmost component, you'll get a single, when a change happens to the store, you get one update cascading down. Unaffected components don't re-render, so you sort of get a good performant by default strategy. Relay also has things like optimistic mutations. So Sashko talked about adding, this is coming to Apollo. So these are available in Relay today, optimistic updates. So if you toggle the like button, we can instantly toggle the color. But for example, the like sentence is a more complex thing. We need that from the server. So we'll send that to the server, get the response back, and then update with more information from the server. We also can handle things like multiple updates to the same object and actually queue them up so that we don't get conflicting race conditions with our network requests. So a fourth topic, and we haven't really talked as much about this in past talks, and I want to focus a bit more on this today, is performance. So Relay was designed and kind of built for real apps. We actually developed Relay alongside several example projects, and then integrated it quickly into some production applications. And today, every substantial diff or change that we make to the system is profiled on multiple real apps running on real devices. So we actually can tell what effect is this change going to have. And so sometimes we actually have to take a regression. There was a pull request from the community that had like minor, very, very minor perf regression, but it did fix a bug. And so we said, well, we have to take the hit. But other times, we're able to see that we know that this change is going to make a real benefit for our applications. So let's look at a couple of the ways that we're able to achieve really good performance. So on the left, we have a sample, like a very, very simple fragment on node ID. And this relay.ql tag, we have a Babel plugin that analyzes this and transforms this fragment. So on the right is what is actually produced by this. So you'll note that it's an immediately invoked function. This allows us to have local scope, and it returns a simple object description of the query. So again, rather than parse this at runtime and have to examine a very, very complex AST, we have a simple description of the query that we can use to read the results, write the response from the server into the cache, and we have a bunch of what we call traversals that walk over this data structure to process queries. So again, we're using some static compilation in order to optimize what we do at runtime. You'll also notice, we only asked for ID, but there's actually 2 children here. You'll notice that we're also querying for type name. So that's something that Relay dynamically inserts. It says, oh, node is an interface. I don't know statically what concrete type the response is going to have, but you might care about that. You might want to say, if it's a picture, do this. If it's a video, do something else. And so Relay will automatically insert the type name field. If we didn't add ID, Relay would also add ID for us. It would say, is ID a valid field at this type? And if it is, I'm going to query it for you so I can better normalize the results. So again, by doing these things statically, we can optimize the query much more and have a much better developer experience. Another thing is our code. If you look at the code base, you'll see a mix of object-oriented, functional programming, immutability, mutability, caching, memoization. We've really looked at a lot of different strategies for optimizing the code depending on the actual use cases. So for example, our queries are immutable objects. And what that means is when we diff them against the store, we get a new object, but you'll see that the new result is actually referencing items back in the query. And again, if you've watched one of Lee's talks about immutable JS, you'll probably recognize this because it's basically how immutable data structures work. So we're avoiding creating lots of new JS objects, which reduces pressure on GC and improves performance. So here we're looking at an example of immutability. In the store itself is a mutable object. So we've actually looked at using immutable JS for the store. This is the question that just came up. And it actually caused, and we actually ran an experiment, and using immutable JS for the store would have caused at least a 30% performance regression on several of our applications. And so this is an example of where actual profiling on real apps in production allows us to make better decisions about how we architect the framework. So another thing that we've done for performance is look at how we schedule the work that Relay is doing. So there's a lot of complex things that are happening, constructing a query, printing it, sending it to the server, processing responses. But the key thing is that everything that Relay is doing is technically behind an asynchronous interface, right? We're asking, fetch some data and give me back a result later. Obviously, it's got to go to the server. So now that our interface is asynchronous, we have a lot of flexibility in how we do that asynchronous work. And so what we've done is chop up the core stages of our processing pipeline into tasks. And we have a task scheduler for how to run them. So at the top, you can see we're injecting a scheduler that says, given a task, run it right away. And this is really, really great for startup, because everything we have to do, we just get done as fast as possible. Because really, we're just sitting there with a loading spinner. There's nothing else that the user could be doing. Once we've shown something, though, we want to be really responsive, right? If the user taps, we want to handle that right away. If there's animations going on, we don't want to interrupt that. And so on the bottom, you can see using setImmediate, where we're kind of breaking things up via the microtask queue. And even better, on the bottom, using React Native's interaction manager, which allows us to schedule work around animations or gestures that may be happening. So this way, you get a nice, smooth animation or gesture, and at the end of that, Relay will continue doing its work. So a lot of people are using Relay on the web in open source. Internally, Relay was originally built for the web, but we're predominantly using it in React Native. Of course, we're using it on the web too, but our primary focus is on React Native. And I think a lot of that is that on mobile, a single round trip to get our data is really important. On a 2G network, the round trip time can be 2 seconds or more. So having a single round trip is really, really important. And so this is so some examples of where we're using this in React Native is the Groups app and the Ads Manager app. So these are 2 apps. Ads Manager is 100% React Native and Relay. Groups, the Groups actual feed, that's Relay and React Native. Okay, So that's a very, very brief whirlwind tour of kind of where we are and today with Relay. So all the features that I described are built and exist in Relay today. So it works well for our use cases. We have dozens of teams using it on public products and internal tools. And just to kind of go over, I think what we found really, really works about Relay and where we get the value from it is the co-located query and render, being able to reason locally, the automatic caching and data fetching, the automatic component data subscription, so not having to worry about is my component going to render correctly when data changes. The declarative API aligns with the React mental model. So developers kind of start, and we still get questions today in our internal React Native support group where people are saying, React Native isn't fetching my data correctly, or something weird's going on with data. And we're like, actually, you meant Relay, because it really does line up really well. Also mutations. So again, optimistic mutations allow us to get these really, really great responsiveness. So user taps something and something they see immediate feedback, and yet we can have a much more complicated process to go and correctly update the server and get more data back. And finally, global efficiency. So this is, Relay as a framework allows us to make an improvement in one place and see benefits across multiple applications. And so that's been really powerful. So I'm probably already running out of time, and I'll try to make this quick. But so some of the ideas that we're focusing on for the future. The primary thing is that we're really looking at, as I said, Relay was originally built for web, and as we move forward, we're looking at how to completely optimize Relay toward especially low-end mobile devices. And so the kind of a few of the top-level things we're looking at there. Static queries, first-class pagination API, integrated garbage collection, right? That we have possibly constrained memory, and so we don't want to just arbitrarily have the cache growing. More expressive mutations. Previous talker, I think Sasko and previous questions kind of alluded to mutations being a little bit limited in Relay right now. They solve the vast majority of our use cases today, but we want to make that even better if we can in the future. And then finally, making the system a bit more modular. So having a clear separation of concerns. Relay is kind of already architected that way internally, but it's not really exposed to the user, and we want to make it easier to kind of put the pieces together in a way that makes sense for you. So let's start with static queries and kind of compare them to what we have today, which is dynamic queries. So today, at build time, we transform those relay.ql tags into queries, as I showed before. And at runtime, we have to actually execute that function and do a bunch of work to actually construct a query representation for the entire tree. We then have to take that query object and convert it into a string in order to send to the server, which we actually upload all of those bytes. And then we get the response back and process it into the store, and then we can render. Well, what can we do to make this better? So here is what we're looking at in the future. Transforming relay.ql tags as we do today, but statically via some directives and extensions, basically kind of extending the GraphQL syntax via directives. We're able to express everything we need to about a relay query statically, 100% statically, which means we can construct the query at build time, print it to a string, save it in a database, assign it an ID, and then at runtime, we can just send a simple ID and variables up to the server and process the response. We're also looking at a few things where we can basically compile and possibly optimize that query to make that processing step faster because we had more information available at static time. An example of that would be if two different fragments are both fetching the ID field, we don't have to process it twice, we can process it once. And we can, we can kind of compact the query statically. So pagination, and again, this came up earlier about the kind of Relay's approach to pagination. So today, we have a built-in assumption in the store about how connections work. And that has some advantages. So this is the API for fetching more information. A component would call set variables and say, hey, whatever count I had before, just increase it by 10 and go get me the information. Because Relay doesn't actually know what this count means, though, it has to do, it is very magic. It's going to do that diffing we saw and do first 10, it's first 20, and kind of figure out the difference between what we're fetching and what we already have. But Relay can't do very many optimizations on this because it doesn't know what the variable represents. So in the future, we're looking at a new top-level API, Relay connection, where we can say, fetch first 10, fetch first 20, and basically subscribe to the list of edges. And this will allow us to say the store internals don't know about connections, but the Relay connection API does. So if you want limit offset, you can build Relay connection that uses a limit offset approach. Again, kind of the plug-in model of building a higher level component given these low-level pieces that we've provided. And finally, on mobile, resource management and memory is really important. And a lot of people have asked about garbage collection. It's pretty easy to build a normalized cache. It's a little bit more challenging to also get rid of the data that you don't need anymore. And so an example of this would be, let's say we've got a feed with some media items, and on the left we have the actual normalized graph. Let's say that we scroll away and these media items go off screen, so they're not going to be rendered anymore. But they were the only ones referencing this data, so do we want to just hang on to it? Well, probably not, because if we did that, then over time we just have lots and lots of data in the store that we don't need anymore. And so we're exploring a few different architectures for how we can get garbage collection built into the store so that we always have only the data that we need, while also giving you some control to say, well, actually, I want to prefetch some stuff. And it's like, hold on to it, because I'll need that in a second. So we're kind of looking at a bunch of different APIs for this. A few things that I didn't go into as much detail, but more expressive mutations. So an example kind of proposed API would basically be that you just tell us what to do to the store. At a low level, basically you get to just write stuff into the store, and then we can provide higher level abstractions on top of that. But basically, if we give you write functions, then you can do anything, and that would be, that would solve pretty much any use case. And again, as I mentioned, making things more modular. So these are some of the ideas that we're pursuing. There's kind of a few more things that we'll see how they turn out. But this hopefully gives you an idea of where Relay is today and where we're going. So thank you.
Okay, we can take one question from the audience.
Regarding React Native, I know that you guys were exploring either running Relay or parts of Relay in a web worker, or running maybe parts of Relay natively. Is that something you guys are still exploring, and is there a plan to open source anything around that?
So the question was around React Native and whether Relay was exploring options for either running them in a web worker or running natively.
Yep. Yeah. So we actually did a couple experiments about running Relay in a web worker, and that was kind of the idea of can we move some of the processing off of the main JavaScript thread? And I think today the main thing that we're exploring is really actually not so much moving work off of the runtime thread, but basically just don't do that work at runtime at all, and just simply move the vast majority of processing to static build time and have a very, very minimal step that runs at runtime. So basically anything that we do end up using in production, we'll obviously open source it, but that's the main avenue that we're pursuing right now. Yeah.
Okay, let's thank Joe again.
I should just briefly add to the question. We did see that using a web worker actually incurs a bit more memory because we're running basically a second copy. So that was kind of part of the trade-off there. Sorry.
Okay, our next speaker is Clay Alsop. Clay is the creator of GraphQL Hub, which is a website, but also an open source project where you can query APIs like GitHub, Twitter, Reddit, Hacker News with GraphQL.
Oh no! What's going on? What? Oh, there we go. Very cool. How's everyone doing? You guys excited about GraphQL now? Right? Right? All right, cool, cool. All right. Did this work? This didn't work. Oh, man. That's a bummer. I know, right? Let's try this again. Deck set. Come on. Cool. Oh, no. Oh, no. Okay, I have a backup. One sec. Deck set. All right. Export as PDF. Cool. Aha. And then if I do this, there we go. Sweet. All right. Doing it live. Cool. So I'm going to talk about evolving GraphQL Hub. And as we were saying, did this work? Yeah, this kind of worked. Oh, well. GraphQL Hub is a way to query popular APIs using GraphQL. So for example, like Hacker News, Reddit, Twitter, existing REST APIs. And it's a website. So you can go to GraphQLHub.com. You can poke around. It's also an NPM module. So if you ever want to like include the ability to query Reddit or Twitter using GraphQL in your own apps, you can just NPM install GraphQL Hub schemas, and you're good to go. There's also a Medium publication where I write about a lot of like GraphQL in-depth topics, which is also cool and under this sort of like umbrella. And that's GraphQLHub.com. Can I do this trick? I can do this trick. Sweet. So like we've demoed a lot of graphical, and this is an example of our graphical using the Hacker News schema that we have. So you can see that we're getting a bunch of data from Hacker News, a bunch of like posts. We're getting the authors. We're getting all kinds of really awesome data. On the side, you can kind of see the different APIs we offer and how this is part of the schema. I won't go into too much in depth, but it's fun. You should play around and put in your own Twitter handles or Hacker News handles and see what's out there. But the interesting thing is how this has evolved over the past year or so. Whoops. Cool. And basically, it started with these REST APIs that I converted to sort of like GraphQL queries. And then I kind of got a better understanding of GraphQL after doing this a few times and made a more idiomatic approach to GraphQL. And that's a version that's more compatible with Relay. And then I also, like, as more people started to use the service, looked into performance and how do you actually instrument a GraphQL server. So the first part of this comes from like Relay. Like I thought Relay was very, very cool, and I wanted to build some apps using Relay. But one of the prerequisites of Relay is that you have a GraphQL server, and I didn't have one of those lying around in August, and like no one did. So I decided to roll my own. And what I wanted to do is I wanted to write this. I wanted to write like an article on how to build a Hacker News client with Relay, which seems like a really cool way to dog food Relay, right? But there's no Hacker News GraphQL server. So instead, when I wrote this, I said, hey, you can use this thing called GraphQL Hub. And that lets you query Hacker News using GraphQL. And in turn, that lets you use Relay and lets you collocate queries and do the awesome stuff that Joe was just talking about. So this was the version of the schema at that point in time. So you can see like we're getting the top stories. There's this like by field that returns an ID. There's this thing called kids, which seems kind of funky. And a lot of this is actually derived from the actual Hacker News REST API. So the Hacker News REST API like uses the word kids. It uses IDs, score. These are all like nouns that I borrowed directly from the REST API. But one of the cool benefits of having this on a GraphQL server is you can see in the original Hacker News API, these kids are actually just IDs. And so if you want to actually find a piece of information for this kid, you have to do like another REST query. And so if you want to do like in kids, you have to do in REST queries. And doing that on the client would kind of suck. So this is all actually a little bit done in parallel on the server. And that's one of the benefits of GraphQL is you can do these kind of like parallelization optimizations, and the client doesn't have to know about it. And that's like for a more extreme example, we're getting 5 kids, we're getting 5 more stories based on those. That's like 25 total REST API calls. And this is all done on the server, which is nice, and it's all very declarative. And it lets us write this at the end of the day. A nice little Relay container for a Hacker News story. And so as like a person writing an app, a mobile app or a web app, all I have to do is drop in this little bit of GraphQL and I'm good to go. And so that was like around September-ish, and I added more support for like Hacker News, Twitter, Reddit, some more. I didn't actually add Twitter. I'll get to that in a minute. But the next part of like my exploration of this ecosystem was actually doing mutations. And mutations are a little bit more complicated. than just getting data. Mutations are an inherently hairy thing. You need to change the data in a way both on the server and the client, and have some kind of loading state while that happens. Maybe do an optimistic update. And the cool thing is, if you use Relay, Relay has a very kind of well-defined system of how to do mutations. But to buy into it, you have to buy into all the other mechanisms that Relay prescribes. So essentially, Relay assumes that your GraphQL server isn't just random GraphQL, it's actually a well-defined GraphQL structure. So for example, it expects a top-level node field where you can query any object in your entire universe of objects. It defines a structure for pagination, which Joe was just talking about. And these are things that most REST APIs don't support out of the box. A lot of things, as we've talked about, use limit and offset. They might do cursor pagination. They might do it in some other funky way that's not quite the way that Relay thinks about it. And so to make this illustrative, the way that Relay wants you to think about it is as your data as truly as a graph. So you can query any of these different objects in your graph independently. You can query the current user, or you can query any comment or post and the edges connected to them using globally unique IDs. And so the problem with the original Hacker News API I had kind of constructed with GraphQL was that it didn't conform to this at all. It was just kids and these other nouns and verbs that really didn't really know what to do with. And then I kind of evolved that into this new version, which actually has proper pagination. So you can see that there's a page info thing, which tells you information about how the cursors work. It uses edges correctly and cursors and nodes. It uses query fragments to pick out which type of node you're going to return. And the way I think about this is actually as idiomatic GraphQL. So instead of a hodgepodge of different techniques, this actually adds a little bit more formal structure to your GraphQL endpoint. I'm sure everyone's used different REST APIs where they might all nominally be REST, but they have very different patterns between them. And I can imagine that very easily happening with different GraphQL servers, where if you kind of take your application of REST and then just kind of port it wholesale over to GraphQL, you're going to end up with a very different ecosystem of GraphQL queries that's not going to be portable or take advantage of a lot of the client-side work, like in Relay or other GraphQL clients that are coming down the pipe. So eventually I arrived at this conclusion that, hey, I should adopt this idiomatic GraphQL structure. And along the way, more people started using GraphQL Hub. So performance is really important. Here's a rough graph of the queries per day for GraphQL from the past week. I don't know where a lot of these come from, but it's pretty cool. And it's enough data to actually have some interesting instrumentation behind. So this is the number of raw queries that GraphQL Hub gets. And this is the queries broken down by which field and resolver. So you can see the Hacker News API calls are broken down. They take approximately less than a second. Some of the Reddit API calls are super fast. And then there's a lot of fields in here that I've just omitted because they're in memory and they're instantaneous. And note that this is the 50% time, so basically median. And then if you go to 95% of the time, there's some funky Hacker News API calls that take over a minute. And it's really important to instrument this. Whenever you eventually launch a GraphQL server in production, you want to understand how it works. It's not like in REST where you can kind of instrument each endpoint. Like in New Relic, you're going to have one GraphQL endpoint, and you actually need to instrument the system a little bit more in depth. And it still isn't really understood in the open source community how you do this. It really depends on what implementation of GraphQL server you're using. In this case, I use the vanilla JavaScript one. And you can actually go on GitHub and see how this works. It's basically a drop-in middleware that you add, and you can pipe it out to. In this case, I'm using Keen.io, but you can imagine putting it into StatsD or whatever other metrics service you want. And finally, it's really cool to see as I've kind of made these changes and took this little journey with GraphQL, how the community sort of responded. So for example, the Twitter endpoint on GraphQL Hub is entirely a community thing. It was just a pull request that was open one day, and I thought it was super awesome. And again, this is all like open source. If you're interested in how any of this code works under the hood, or you want to contribute back to it, like, go for it. And here's an example of that Twitter endpoint. So you can see that like this is still kind of using a lot of techniques that are just taken from REST. So for example, tweets returns an actual array of tweets, not like a pagination construct. And it's actually kind of hard with APIs that don't natively support cursors to add the kind of cursor-based pagination. And so it'll be cool, throughout this year to see more and more APIs adopting that, perhaps using GraphQL natively or inside of REST itself. So yeah, I know that was a really fast talk, but thanks for listening, and check out GraphQL Hub. It's pretty neat.
Do you have any questions from the audience?
Curious if anyone's tried wrapping the Wikipedia API in GraphQL?
So the question was if anyone's tried wrapping the Wikipedia API in GraphQL Hub.
No, that sounds really cool. You should do it. I have like an open PR for the Facebook API, which I think would be kind of interesting to see in GraphQL. And I'm sure like this guy has an opinion on how it works. But there's so many APIs out there, and it'd be really cool just to see like how well they can adopt to GraphQL, and like go for it. Yeah.
Right. There's another question.
Can all of the APIs be consumed by Relay?
So the question was if all the APIs can be consumed by Relay.
So it's actually pretty funny. The first Hacker News GraphQL binding I did basically worked with Relay by coincidence. It happened to be that all the IDs in Hacker News are universally unique. I didn't like impose any restrictions, whereas like in other APIs, that's not the case at all. Like Reddit, like some of the Reddit APIs are like you're going to get ID collisions unless you do something more intelligent. So for now, the Hacker News ones there's a mutations API that's just like a simple key value store. That's definitely compatible with Relay. The other ones probably need a little bit more love to get up to like the pagination sort of stuff. And again, like PRs would be awesome if you're into that. So, yeah.
Oh, there's one more question.
Is there anything, with your experience building GraphQL Hub, is there anything that you would change if you could about like the core design of GraphQL or Relay?
So the question was, with your experience of building GraphQL Hub, is there anything about GraphQL or Relay that you would change if you could?
I think a lot of the work the Apollo folks are doing, like with integrating Redux into like a GraphQL client, is pretty cool. Besides that, like I'm interested to see how instrumentation and performance factors in as more people adopt GraphQL more widely. I think it's not a very well explored or understood thing. Like there's some really awesome issues that have comments on it, but there's no real like drop-in solution right now. So it'll be cool to see like how that evolves. But nothing specific to the actual like format of GraphQL or anything at this point.
Okay, let's thank Clay again for his talk. Okay, now we have a short break, and after the break, we'll be back with a panel discussion about GraphQL. And Lee Byron, the maintainer of GraphQL, will be joining us for that panel, so make sure to stick around.
You have to differentiate. So I think that's really
hear the audience a little bit.
Yeah.
It helps. A few of those questions, especially on their front row, I totally catch them.
I'm similar to you. Like, I'm afraid that there'll be abuse. People advocates.
Lee's joining.
Yes. Yes. There you go. Nice.
That's like a long.
Yep.
Like, that's going to be, for us, multi-year project, where sooner rather than later, we want
Sweet.
to like share the results of it.
Winning.
Giving people
Full screen it.
at
You should be able to just go view full screen, or you can just hit the green. You should be able to hit. You should be able to just hit view full screen.
Yeah.
guess.
So you were showing code where you do like username equals graphics plus stuff. If you use the Django integration, would you like define a Django model and then basically auto so that just might be a function. Is there automatically like if you have an object like comment, like is there basically like an automatic like create comments sort of thing, or like do you go and create comment? Like if when I'm going through a workflow and it's like hey, I should create a comment class, and sounds like I'm using some type of graphic language, go to my Django model and I create a comment class there. Wait, now so graphics at that point is something is automatically created, right? Is it or no, or it's just actually
Okay, everyone, let's try to get back to your seats so we can get the panel started.
Panel person.
Line up with your face.
Oh, that's a good idea.
I've made this mistake before. I know.
Line up in the wrong order.
Yep.
Now I feel like we're on a team or something. Like follow team and Facebook team. Bill, you. At least we're not all wearing the same color shirts. I guess we are. That's kind of weird.
Oh my gosh.
I feel like I went.
Very bright light.
All right, we have a really great lineup here for our panel. You've already met 3 of the people on the panel. The 4th person is Lee Byron. He is the maintainer of GraphQL and also Immutable.js at Facebook. Anything else?
So many things.
So many things. No, those are my 2 major projects. I also maintain a project called Data Loader, which is often used with GraphQL.
It's a good one.
Okay, so to get this panel started, I wanted to ask a question actually for you, Lee, which is a question that we often get. Is like, okay, so what's next for GraphQL? What's your vision?
There's a lot to do next. I can kind of like chop it into 2 buckets. One is kind of where like the kinds of problems that GraphQL can help us solve. So GraphQL is already really good at solving I have a question, I get that data, and I get it back. I can do it in as few network requests as possible, and I can chop that up and co-locate what the data I need with the views that end up rendering it. So I can already do that. But what it's not good at yet is managing real-time data, managing data that's like the time to the most important piece of data in your query. So we often like chop our stuff up into different GraphQL queries where our important stuff is here and then everything else is over here. So I think we can probably do more to improve on those. But then the other bucket of stuff that I actually think is even more important is all the different tools that we need. So GraphQL is, we release a spec and we release a reference implementation, and a lot of the work that's happened so far has been kind of filling in the blanks on the server so that we can actually build GraphQL services. And now I think like the big next step is building good client tools. And you guys have been really beneficial with Apollo, but most of the work we've seen so far has been in JavaScript and for the web. And the reality is that most of application development right now is happening for mobile, specifically like native apps. And there just hasn't been a lot of experimentation with GraphQL clients for iOS or Android apps yet. So I'm really excited to see that kind of thing happen.
Yeah, it's really great to see that even though GraphQL is like relatively new or like hasn't been released as open source for very long, there's already a lot of excitement out there and people are using it and the tools are kind of maturing. And that kind of brings us to the next question that I wanted to ask, and that's kind of for everyone is, everyone has kind of a different story of what brought them to GraphQL and what they're most excited about. So I'm kind of curious to know, what was the thing that you really thought about GraphQL? Oh, that's so amazing. Like, I want to start using that. Maybe this one's for Cyrus.
Okay. At the beginning, I was invited to the Facebook offices, and they were releasing they were saying that they will release GraphQL soon, and what was GraphQL about. And at the beginning, I was not believing GraphQL. I was like, that's not for me. That's gonna work for Facebook, but I don't know. Like, it's not gonna work in my kind of structure of backend. But actually, when they open source the GraphQL JS implementation, I start seeing like the value because I could play with it. And when I start playing with it, I could see like all the value on GraphQL and not just like one fetching in just one response in one HTTP response, but more than that, like the way the types were defined, like also that we avoid versioning, API versioning or normal API versioning. So there are a lot of cool things. And more than that, for me, the introspection was like the main thing. Because with introspection, you can have validation, you can have like GraphQL or whatever other tools you want to build on top of that. And that's a very big thing.
Yeah, I can go. So I've been working at Meteor for about 2 years now, almost, and we actually took a kind of funny detour to get to GraphQL because I think a lot of people are coming to GraphQL from REST or from something like that, like HTTP requests. But Meteor has a totally reactive, completely real-time WebSocket-based pub/sub system. And how we got here was we were actually thinking about like how can we bring the experience of using a real-time WebSocket system that relies on live querying the database, but to every backend. And it's funny because we also ended up at GraphQL. We started thinking, we were like, okay, we need to be able to aggregate data requirements from different components. We need to be able to have an agnostic language to query from different databases. And even though GraphQL at the time and still doesn't really have too many first-class primitives for reactivity or real-time built in, we figured it gave a very similar experience to what you got with Meteor, which is the core of the experience to me was just you asked for data and then you got it. And GraphQL is just like the best way of asking for data that I can think of right now.
So I was building React apps about 2 years ago at a company, and we were just constantly faced with the question of how do we get data into our apps. And I went to a tech talk at Facebook and heard the very vague, what you can say, what we could talk about publicly at that point, description of like, we have this thing that lets us magically get data. And I saw enough that I was like, yeah, that's pretty cool. I want to work there. And so naturally, when I joined, I work on Relay now. Yeah.
How about you, Lee? You kind of were around when I think GraphQL was open source.
So GraphQL just recently had its 4th birthday. Its first birthday as an open source project, but it's actually been being used at Facebook for quite some time before that. And I was part of the small team that co-created GraphQL. And Nick Strock's in the audience, who's also on that team, and then Dan Schaefer, who isn't here today, was the 3rd member of our team. And what we were really trying to do, I think all 3 of us came kind of with different goals and intentions. And my intention was to rebuild our iOS app, and specifically rebuild the newsfeed part of that app. And this was 4 years ago, 2012. And I don't know if you remember what the Facebook app felt like in 2012. It was pretty awful. And we had a lot of problems to solve, and one of the big problems to solve was making sure that we could get all of the information down the pipe quickly. And before that, we had used kind of a hodgepodge of different technologies, including our Facebook RESTful API, including another Facebook platform technology called FQL, which is kind of like an SQL-like syntax, will let you query Facebook data. And all of those had kind of their own problems. And Nick actually came with the idea, like the early idea for GraphQL, as the evolution of all of the work that he had been doing for like his previous years at the company, which was like getting a stronghold on the data in our actual server. And the next step was like, okay, like we have a really good way to represent data in PHP, but clearly development is happening outside of that now. And how do we bring the strong types and the kind of like async nature of fetching data and bring that outside of PHP? So Schrock came up with the first version of GraphQL that did that. And another member of our iOS team kind of like saw these 2 things happening and connected the dots. And so he introduced Nick and myself together. And then Dan, who's working on the newsfeed team at the time, we were working close with him because we were doing newsfeed. And like all of a sudden, like our 3 minds like exploded. We were like, holy crap, like this is gonna work. And we just kind of like didn't sleep for a good 3 weeks. And eventually GraphQL came out of that. 4 months. Well, we slept after. Relationships were lost.
Yeah, I think that's kind of that's a.
I meant 3 weeks until we slept. Not to say we didn't stop working after that. Yeah.
Okay, so it seems like you experienced like a very extreme form of what everyone experiences when they discover GraphQL, that they're really excited about it.
Yeah, except that like usually people, each feature that they say like, oh, and it does that's really cool. Except that we were discovering that via like code review, where someone would come up with a cool idea and then put up the code, and then the other 2 of us would be like, whoa, yes, like this is going to be amazing. And it like GraphQL started kind of as like a much simpler version of what it is now, or at least like fewer of the like core ideas. The primary core idea that was there from the very beginning that Nick brought was this like hierarchical fetching of data. So that was there. But then we started to introduce the type system, and we started to introduce features like fragments to break things apart. And like each one of these features got introduced kind of over time in that first kind of year of GraphQL coming together. And every time it landed, like our iOS and Android teams would take it and run with it and build all kinds of cool stuff on the client. So yeah, we got to have those mind-blowing moments, but spread out over time.
Yeah, I think one thing that's actually really cool about GraphQL is like, it's one of those things where there's so many different things that could be separate technologies. Like you could have just REST with typed APIs, or you could have just nested data fetching but without typing, or you could have all of that but without a query language. But I feel like when it all comes together, that's when the magic happens. Like each of those things by themselves are not that exciting by themselves. Super cool.
Yeah. One thing that's always very interesting in open source projects that kind of take off and become very popular, that a lot of people want to contribute, but it's not always easy to kind of manage all these contributors. Or sometimes you feel like, okay, yeah, people want to contribute, but they don't actually make good pull requests, or they don't file issues the way that we'd like to. Or actually, you're doing an open source project and you want people to contribute, but somehow nobody's showing up. So I'm kind of curious to know from all 4 of you, like, what's your experience, and kind of how do you manage that, and how would you like it to be?
I could start. So with Graphene, I just started alone, as like all open source projects. But I was believing that GraphQL was like the next big thing after peanut butter. That's a joke I have in the website. So I believe that that was like the next big thing, and I just want to invest my time in something that I believe on. And at the beginning, I was alone. Like I was like, oh, you can use my framework. Actually, thanks for the Slack channel, I started like spreading a little bit. People actually start buying the idea of GraphQL, and of these people, there were some people on Python. So it was difficult at the beginning. Like the first 100 stars was like very difficult, but after that, you get some traction, and some people like get involved in the process. And actually, there was some point that I was working like from 9 a.m. to 6 p.m. in my work, and then go back to my home and work until 2 a.m. like for 3 months. It was exciting because I was creating my baby and was very good. But actually, until one point, like probably like a few months ago, a lot of people start contributing, and from these people, like there are people that are kind of have more idea about like what is graphene and all these things, and you can start delegating. So that's like kind of what I'm doing more right now.
Yeah, I manage a handful of open source projects, so this one hits home. I try to keep this, so I think it's really important for any open source project to have a philosophy of what that project is for. And then that philosophy should guide how that project develops forward, and should also guide how to evaluate pull requests. Because a lot of the times when it gets tricky is somebody comes up with a really good idea and they have a pull request up and they're implementing it, and you're trying to kind of like noodle through what kind of feedback can I give? Should this be better? Does it live here? Should it be its own package? And if you have like a good, solid philosophy on what this package is for and what to do, like what things go in it, what things go out of it, where they live, then I found that helps quite a lot in leading people to do the right thing. And also, it's hard for one project to be like a focal point for lots of development. And I've kind of seen that happen on a handful of different projects before, and the core maintainers end up just kind of like getting burnt out and wanting to run away. And I don't want to have that happen to me. So typically, most of the projects that I maintain have a philosophy, like kind of like the Unix philosophy, like do one thing and do it well, and then have a pluggable model so that other people can do things that work really well with it. And in the cases where it doesn't, the solution is almost never, oh, but you can't do this feature via like a modular way, so we have to add it into the core. And it's like, no, actually what you want is to figure out how to expose a new way to do your thing modularly. And that can sometimes be a little bit tricky, especially when someone's coming in with an agenda to get their feature built and they feel like they're getting kind of the runaround. It's like, you're making me do this extra work to make my feature work. But it's ultimately beneficial in the long run, because that initial work unlocks not only their one feature, but opens up an avenue to have like more of an ecosystem of that same kind of thing. So we tried to do that very intentionally with GraphQL JS as a reference implementation, and we hoped that that would be copied as people built GraphQL in other languages as well. So like the fact that the like middleware pattern is catching on for resolvers, I'm pretty excited about. There's more things that we can do to make it more modular, but making sure that we can have, if you're trying to do something and there aren't existing GraphQL tools that let you do that, you should feel like you have the available tools and support to build something that does it the way that you want to see it done, and it still works with everything else that's out there.
Yeah, yeah, I think that's super, super important. I think like the ability to let people do what they want with your tool instead of having to rebuild from the ground up, I think is always the best. Like for example, people can implement custom types for GraphQL. So now I'm also running into a situation where there's a ton of people out there who are building GraphQL clients with Redux, and so now I'm like, guys, can we all maybe like work together, factor out some libraries, so we're not all have 10 million versions of the same thing. Going back to the original question, the really cool thing for me was we, after we decided that GraphQL was like the best thing ever, we went and talked to a bunch of people, like probably dozens of different people who were using it in production, wanting something like that in production. And the best part was we came across somebody who actually already did the same thing that we were planning to do, which was these guys at New Spring Church that we're collaborating with on Apollo Client. So essentially from the very first day, there were like two halves to the development team where like development would never sleep. Like I would come in, I had some ideas that were like mostly philosophical, and then James would come in and be like, okay, we tried this in our actual app and like it didn't work, so here's like a pull request to fix that. And so that was super exciting. Like, just having, I think, having more than one person on the project, which you can easily just have one person for a long time. It was just super empowering to see like other people's ideas come in.
Yeah. I mean, I guess, I don't know. This is my first big open source project that I've worked on. So, and I think for the Relay team as a whole, we're still kind of figuring it out, and getting good advice from Lee and Christopher Shadow and others at Facebook who have had a lot of experience. But I think what you kind of both touched on of trying to make the framework more modular, that have that Unix philosophy of keep it simple. That's something that Relay doesn't do today, but we've definitely seen over time that there's this very like clear tendency in pull requests to just like add things into the framework. And I think we initially kind of got sucked into that of like, oh, well, all right, how do we make this work? And then kind of once that hit a certain critical mass was like, okay, we got to step back and figure out how to make this more modular so that people can just do what they need to do. Yeah, so don't have too much to add, but yes.
I'll add one more thing to that just because I think it's important. One of the philosophies that Facebook has for its open source program in general is that we only open source the stuff that we're actually using at Facebook. And I don't know if you guys have ever open sourced something that's just totally unrelated to your day job, you've instantly created a second day job for yourself, and then you just like have this guilt because either you're like doing your day job well and then you're abandoning your open source project and you feel bad, or you're spending all your time on your open source project and you're abandoning your day job and you feel bad. And this is not a good thing. And if you open source the stuff that you're using day to day, then your day-to-day work influences not just your own work, but it influences people in the open source community as well. And then there's actually an incentive for when like people have issues or pull requests, they might have found a problem that you will find in the future and just haven't yet. And they're like, oh, this broke. And you're like, sweet, thanks for finding that bug before I did. Let me merge that in. Great, one less thing for me to worry about in the coming weeks. So I tried to make sure that as we've like guided the tools that we release around GraphQL at Facebook, that we're only open sourcing the stuff that we're actually going to use at Facebook. And for all the other stuff, we're like, this would be a great idea, but it's not our place to do it. And we'll kind of like seed it out there and talk to people and try to get other folks excited about building stuff.
Do you ever feel a tension, I wonder, about like stuff that you, like if somebody submits a pull request that you will never need, somehow like if someone came down and told you will never need this feature, how do you prioritize supporting that versus not?
Yeah, I mean, it's like taking it at face value. It's a pretty brutal but efficient like way to filter things. And sometimes that makes some pull requests get filtered to the top before others. I don't know, like at the end of the day, I think it's a good thing because I have a limited amount of time that I can spend dealing with issues and pull requests. And if I flip through the pull requests, I'm like, yes, like I've been wanting to do that for a while and someone finally put up a pull request to do that thing I wanted to do. I'm going to focus on that one first before some other ones. But obviously, like anything that's like, I found a bug, I'm gonna like, oh crap, great. Like I gotta make sure that that's fixing something because we probably have the same bug and just didn't realize it yet.
So we're all like pretty hyped about GraphQL, I think, but no technology is perfect. So I'm curious to know from you guys, like, what are the things that you think GraphQL doesn't do well, and how could that be improved?
I think one thing that, I mean, for GraphQL, you have to control the client because it's the client who decides the data that it wants. And before you have this logic on the server. And when you switch the responsibility to the client, you have to trust the client. So actually, kind of like making a tool, like open sourcing like all your APIs through GraphQL could be a little bit dangerous for like just your business. Or things like that. So, or maybe just like they are gonna do like harmful queries that you don't want to run, or all these kind of things that you have to trust the clients that they are like querying your data, and that's important. But there is no solution for that.
I was just gonna ask, like, how does Facebook actually solve that problem?
Which problem in particular?
Of letting people do arbitrary queries.
Yeah, so first of all, our GraphQL server is an internal server, right? We don't, like, third-party applications can't query Facebook's GraphQL server. So that's kind of like one possible attack vector kind of cleared. The second is we build good tools for client developers to get a good understanding of what they're doing, and so we don't have to worry too much. So like one of those things is that we validate queries on the client before they're even checked in, as like a lint rule. So bad queries can't even make it into the client code bases, let alone to the server. The other thing that is pretty important about how GraphQL works is that you only expose through GraphQL what you know to be possible to make fast on the server, right? And this is why GraphQL doesn't have like a first-class notion of order bys or sort by field or something like that, where you would have to build an index for every, you can write a SQL query that's just like insanely slow, runs n squared on the size of your table. And there's just no way to stop that except having like some poor DBA who sits somewhere and like sees a query and is like, oh, that one again, and like figures out who to whack on the head. And like we don't have that role because we don't have to have that role because we just don't expose the possibility to write a query that's slow. So we largely kind of escape it. Both you can't write bad queries and we like evade the attack vector of like the general public sending us random queries.
Did you ever think about like maybe open sourcing, not open sourcing, but opening your GraphQL endpoint to like the world?
Yes-ish. So the hard part is just the details of how to do permissions and privacy checking and all of that. Facebook has a really sophisticated system for doing privacy checking of data, and there's kind of two sides to the coin. One side is who you are using the service. So like I'm me, and I can see my own data, and I can see Nick's data because we're friends, but only some of it. And I can't see Mark Zuckerberg's data because I'm not friends with him, right? And so when I load data from GraphQL, because GraphQL is just kind of a thin layer on top of our existing systems, all that's taken care of for me. But then there's the second side of it, which is what application am I using to like do these queries on behalf of? And right now, the assumption with the GraphQL server is you're just using one of the Facebook apps. And if you're using one of the Facebook apps, then we're like, great, you can do whatever you want. But if you were using a random third-party app, if you ever used an app through Facebook, you have to like give it permission to do things, right? And so those permissions also factor into those privacy rules, and they, for kind of historical reasons, live in a slightly different system that isn't integrated into the thing that sits under GraphQL, and so it'd be kind of a major effort to do that. And another reason is the way people use the Facebook API is pretty different from the way that we use the Facebook API. We actually originally, like back in 2012, we were really thinking about this should just be the public Facebook API, and then we will use it, right? Like eat your own dog food. And it was actually the platform team that convinced us that this was wrong, because the only people building newsfeed is Facebook. So it is actually not a good idea to expose like a full-featured Facebook newsfeed API to anyone except our own developers. Because as soon as you do, they're going to use it for some like insane other idea, and they're going to rely on it. And then as we need to iterate our product quickly, we'll actually accidentally break some third-party app. So we just avoid all that stuff by having it being an internal API.
So apart from the concern of like clients making dangerous queries, what other things are there that that you think GraphQL doesn't do very well?
So I think any technology it's not about it doing something well or not well. It's about strengths and weaknesses, right? Any technology is kind of like a point on the trade-off continuum. And if we just want to like compare GraphQL to REST, for example, just because that's the most typical comparison, what REST is really good at is mapping directly to an HTTP surface and then reusing all the tools that you get when you use HTTP, right? You can use a browser cache. Anytime some like new HTTP, like HTTP 2 comes out with new features, just like all of a sudden every REST API automatically got an upgrade, right? So GraphQL like picked a different point on that trade-off continuum, because we often talk about like, here are the problems with REST, here's how they're solved in GraphQL, and we're like, yay, GraphQL is better. But to its credit, REST can do a much simpler caching model than GraphQL can, right? So you have a different kind of point on that curve. And actually to say like, all right, great, well then let's use the caching mechanism that REST uses, we would have to give up a lot of the stuff that we find valuable about GraphQL. So I think we end up kind of at like a crossroads between what things we care about and what things we don't care about. And it ended up being the case that we cared far more about the speed over mobile networks and the ability to express the data that you wanted, more so than like a very simple caching mechanism. And so we ended up building complicated caching mechanisms instead.
What kind of limitations of like GraphQL did you run into like building Relay, Joe?
So yeah, it's a good question. I think you can kind of see that in the Relay API. So places where there are things like we have a defer feature that's available internally. We haven't brought that yet to open source, although someone in the community is working on it. But that's the ability to say, part of this subquery, this subfragment, we don't need it right away. So actually fetch everything but this, render, and then go get this data, and then render with that extra information. And so this idea of defer, and like obviously, that could become a directive, and I think we're talking and exploring that idea. Things like so list views, where right now if you fetch 10 items, you get 10 items back. You're naturally going to write all 10 into your store and then render 10 items. But if you could, for example, get one item at a time back from the server, render the first item, render the second item, render the third item, you just get a lot better, buffering and throughout the entire process. So that is something that we are iterating on internally right now. Again, just for performance reasons. So I think it's kind of mainly things that are already like kind of in the GraphQL future like spec and like are kind of that you've been thinking about. Another big one would be so with React we have kind of you're used to the idea of I pass in props and that configures the component, right? So I can have a button and I can choose whether to have it be toggled or not toggled. Or maybe I have a profile picture component that has a size, and we want to be able to configure that size. And so depending on what your UI patterns are, you may have these very, very configurable components, and yet you have a static query. And so right now, fragments don't take arguments, which has a lot of benefits. Because it means that the response shape is predictable. The thing is that if you're building tooling on top of it, you can kind of do more complex dynamic things. And so in Relay, we are able to say, well, actually, that restriction doesn't make sense for us because we're making a dynamic query. And so I think that's one area where if you have this dynamic client, then it becomes natural to want to express certain things. And so we're kind of still sorting out that tension.
Yeah, there's kind of an interesting the historical path of GraphQL, because our iOS app was the very first client that used GraphQL. So we kind of developed in lockstep where the things that made the most sense for how our iOS app would work were the things that we prioritized first in GraphQL. And that ended up actually making kind of like a very happy outcome, because all of the concerns that you face building like a performant and good data-rich mobile application that needs to live on a crappy mobile network kind of happened. And then much later, Relay tried to bring those ideas back to the web and introduce a lot of really cool ideas that we hadn't been doing yet, like actually co-locating the bits of your query right next to the views that's going to render them. That's like Relay innovation, and now we're like trying to figure out how to bring that back to our iOS and our Android apps. But at the same time, Relay, living in JavaScript, which is a much more dynamic programming environment, wanted to introduce more of this dynamicism that like maybe if the ordering of these had been reversed, where the first thing we tried to do was build stuff for the desktop web, and then later tried to build stuff for the iOS apps, we might have ended up with different decisions.
Yeah, that's really interesting. So we're almost out of time, so we have to wrap up pretty soon, but I just want to ask like one last question for each one of you, and that's, if someone wanted to learn GraphQL or wanted to try out GraphQL, where should they go? Maybe Sashko, you can take this one.
Well, I guess we can.
We
can each talk about our respective sources for learning GraphQL.
I was going to say read their blog.
That's pretty good.
Yeah. So that's one thing we have been focusing a lot since we got started is learning about GraphQL in depth and writing about what we've been learning about also in depth. So we do have a blog where we post a lot of that stuff. But I think the blog is not necessarily like, a lot of those posts are quite in depth and maybe not a good place to get started. But I think some of these things like a talk that Steve Lucier gave recently about 0 to GraphQL in 30 minutes was the most stellar display of live coding I've ever experienced. I've been trying to reproduce it ever since in my bedroom, right? But then, Jonas has also a great tutorial that takes you through loading data from lots of multiple data sources, which I think is the best feature of GraphQL, actually, the ability to, his tutorial has a thing where you can load from Mongo, SQL, and a REST API to get fortune cookie strings.
Yeah. For me, I will say like, go and play with it. And play with it like you have the Star Wars API for playing like either in JavaScript, Python, I don't know if in Scala, but you have these things and you can start playing with it and see like how it could fit in your current architecture. And from that, like probably you will find the resources to accomplish what you want. But actually seeing it, the real thing, it's quite valuable. So like your blogs or your posts, like the website Learn GraphQL, I think is also good. But overall, play with it.
Yeah, I mean, all the suggestions so far. Definitely call out Stephen Lucer's talk, Zero to GraphQL in 30 minutes. And then also he has a GitHub repo up that has the examples from that. And I think there's been a pull request to add a different language. I think it might have been Scala example as well. So you can kind of actually see like all the examples, actual code, and run it.
There's a website, Learn GraphQL. That one's pretty great. Everything those guys just said is great. There's also a site called makeitopen.com, which is a little bit more than just GraphQL, but it may be useful to see like what does a real app look like if you're using GraphQL, Relay, React Native, and it like ties all the pieces together. And it is not only all the code that's required. It's the app from the F8 conference. So one of the Facebook engineers built kind of like top to bottom everything like from the server, the iOS, the Android app, the website for F8. And then he wrote a bunch of articles like explaining how the different like technologies he used played out. And they're really excellent. So that's a good resource as well. And then I would just kind of end with there's needs to be more of this stuff. So like if you dive in and say like, oh man, I needed to learn this thing, and it was a relatively like intermediate to advanced topic, and I just like couldn't find a really good article on this, write one. Post on Medium, post it somewhere, or just like message me, because we're always taking kind of guest contributors to the GraphQL.org blog. There's also GraphQL.org, although the content there is not as good as it could be. So let's make it better.
Yeah, and I want to go one step beyond that, which is I think the best way to learn exactly how it works is to implement your own library or your own tool around it. If you go and you find that, oh, like, yeah, I love GraphQL, but like it doesn't do this thing, just try making that thing work. And I think I learned like way more by just trying to implement some stuff in JavaScript than from reading any amount of blog posts.
Well, thank you very much. Those are all really great tips, and I think we had a really nice discussion. So thanks to everyone in the audience for coming, and if you like this, we'll be doing more of this. Well, we'll be doing more of this even if you don't like it, because we're having a great time. But yeah, so make sure to check out our meetup online on meetup.com. And if you missed some of the talks or didn't catch everything, we'll be uploading the videos on our Apollo Stack YouTube channel, so you can go check them out there. I'll also ask like the speakers for links to the things that I recommended, so we'll put them there as well. All right, that's it for today, and thanks for coming.
If anyone has misplaced their phone and wallet, come and see me, because we have it. Thank you.